Since we last spoke a few weeks ago, the world has certainly changed more than I would have seen coming. Just a few months ago, I talked about certain historic realities that some of us probably still remember quite well from their own past. And well, let's just say that a lot of that is hitting a little closer to home now than it was back then. In a previous episode, I also talked about noticeable price inflation, and I'm sure that most of you have seen by now that that was only the beginning. My home country, Germany, is also seeing a perfect storm of such realities like the end of coal mining, the end of nuclear energy, and a heavy dependency on foreign energy resources. To make it absolutely clear, I'm not interested in starting political arguments. We have enough of those already. I'm talking about factual realities and the options that individuals such as you and me have to survive in this world, in which many of us have given up on bureaucratical and political solutions to our problems. Or in other words, I'm not going to wait for the government to save me from inflation and energy shortages. All I'm trying to say is, I will continue this video series as I used to, but I will try to place a particular focus on the issue of energy production, energy savings, and independence. In that sense, let's see what we will find on the scrapyards today. Now, here is a huge pump housing. Unfortunately, the actual impeller and motor are missing. Look at this blue enclosure here. It's apparently from an old heating system. Well, we will salvage parts from it and then we can reuse the enclosure to fit this in there, and we will build a photovoltaic island system with that in this episode. These are the remains of a motorized wheelchair, but it's unfortunately beyond reasonable repair. Some might say the same about this old cabinet, but I really like it and we're going to take a look at it. Do you see what I see? Pretty cool hand truck, but it's comically large. You see that blue basket? That's a normal size laundry basket. This thing must be 2 meters tall. We're also going to buy this mystery part that maybe some of the American viewers might recognize. And last but not least, I also recently found this old 2-stroke engine that will lead me to an entirely new series of adventures. Let's have a look at that steel cabinet then. As you can see, the old paint job is in pretty bad shape and we'll have to apply new paint here, of course. And because of the dent on the top of the cabinet, the door is also not opening very smoothly anymore. The insides show signs of wear, but nothing too bad. What makes this cabinet more interesting though is this logo. It tells me that it was manufactured by a company called Mauser or Mauser-Waldeck. Not to be confused with the arms manufacturer of the same name that you might know as the manufacturer of the Car 98K, for example. Mauser-Waldeck made all kinds of objects from steel, but also made stylish design furniture, like this desk of the Rundform or Round Form series. If you would happen to own one of these desks in good condition today, you would have a treasure on your hand. Now, of course, this old steel cabinet here is not a valuable collector's item like those desks, but I appreciate its rugged simplicity, and that's why I want to repair it. And in order to do that, I have to beat out this dent as much as possible. I will not be able to do that though without heating up the steel, and that's why I begin by removing the old paint around that dent. After taking out the shelves, I begin to heat up the top of the cabinet with my oxyacetylene torch. I do that with the dent itself, but also with the surrounding areas. After a few minutes, I start to beat out the dent with a hammer from underneath. I actually try to push the metal a little too far here. Rather than one big dent, we now have a number of small bulges that I will try to even out by heating the metal up once more, but now also using this heavy steel plate as a sort of anvil. The cabinet is placed on its side and the plate is fastened on the bottom of the sheet. And after reheating, I use a smaller hammer to flatten those bulges by pressing them against the steel plate. I'm now letting it rest for a while for the steel to cool down, before I start to wire wheel the surface again. And after also preparing the surface with a degreaser, I apply a new paint job. And after a few days of drying, this is what the cabinet looks like now. And a little before and after comparison. It's not like new, but it's good enough for my workshop, and even the doors open smoothly once again. How about we take care of that little engine then? It's a 2-stroke gasoline engine manufactured by Fichtel und Sachs in 1971, even though similar engines by that company have been around for even much longer than that. Fichtel und Sachs got really big by manufacturing bicycle parts and ball bearings, but they also made small engines that were built into bicycles, mopeds, and light motorcycles, lawnmowers, and so on. Both before and long after the war, they also built engines for non-mobile applications, and this is one example. In German, these are called Sachs Stamo, which is short for Stationärmotor, meaning stationary motor. The one we have here is a Stamo ST30 with 30 cubic centimeters of displacement and is supposed to run at a pretty fast 4,000 to 7,500 RPMs. And at 7,000 RPMs the motor is rated at around 1.7 horsepower or roughly 1.3 kilowatts. This particular model was often connected to pumps. Someone has put a rag into the opening for the spark plug in order to block dirt and dust from entering. The hand starter is missing and the engine also appears to be stuck. On the other side we find a reduction gear, and I will remove the gearbox because I'm not sure what's keeping the engine from spinning. The problem could also be inside the gearbox. But after pulling it off the engine housing, I can tell that the gears are moving just fine and that there is no damage or dirt inside. New lubricant would be needed though. But before I do anything else or remove any other parts, I take off the carburetor to clean it. I also clean the outside of the engine wherever I can. While that might seem non-essential to some people, an official German Army handbook explaining the maintenance process tells you that you should always clean the outside before removing parts, because otherwise you might introduce that dirt into the insides of the engine. And while trying to open the fan guard of this air-cooled engine, I first thought I might have to remove the magnet flywheel as well. While I was simply trying to unscrew the nut from the flywheel, I accidentally got the motor to spin freely again. Let's hope that there is no major internal damage. My assumption about the fan guard was wrong though, and I can open one half with the flywheel in place. And then I, of course, clean the guard from the inside as well. According to an old Sachs repair manual, a number of special tools are required to disassemble the engine any further. I will most likely have to make some of those tools myself. But before I will even start to do that in the future, why not try to get the engine running now that it seems to rotate without any perceivable resistance other than the engine compression. In the background you will see the frame of an old army generator. It has a gas tank that I hooked up to the engine. It takes a 2-stroke mix of 1:25. Since the manual starter is missing, let's try it with one of my battery drills. I can feel combustion here and there, and a little bit of smoke is coming out of the muffler, but it won't start yet. Well, let's try it then with our trusty Metabo drill from episode 1 of this series. This is episode 29, by the way, and all other episodes are linked down in the video description. And it roars back to life. A lot of dirt came out there. Let's go outside then and run the engine for a little longer. And that's all I have to show at this point regarding this particular engine, but I have now kind of fallen in love with these stationary motors since I got my hands on this particular one, and I acquired a number of older gasoline generators, most of them German Army surplus, the repair of which will be covered in future episodes. You know, since power outages might become an issue in Germany sooner or later, I figured it's a good point in time to bring some of my interests, namely power electronics and Sachs Stamos, together, but more about that in the near future. Let's have a look at that old blue enclosure then. I mentioned already that I want to use this for an island-type photovoltaic system. But what exactly do I want to do with this part? Well, you'll see in just a minute. First, let's have a look at it. It appears to be a control unit from an industrial heating system from maybe the 1970s or 80s. Let's have a look inside and see what we find. What we have up here is a cam timer, aka a drum sequencer, in German Programmschaltwerk. Basically an electromechanical timer. This is a relay board that belongs to the hydrotherm control unit. A set of fuses and a number of contactors. The black one is really old, while the two white ones on the left are of a much more recent type, probably replacements. 4 starters. In German we call them Motorschutzschalter, meaning motor protection switches. These were probably made by Klöckner-Möller, and by now their plastic is yellowed and very brittle. A Finder brand timer relay, probably much newer and also a pretty expensive component. And 5 more 3-phase contactors. In case you're wondering what contactors are, well, they are basically a special type of relay, but unlike ordinary relays, they can also usually run on AC, and at least here in Germany, they are usually for 3-phase loads. The German term being Schaltschutz. You can use them to switch heavy electric loads with a relatively small control current. On the back side of the door we find the old control unit, a bunch of switches and indicator lamps. The old nameplate says that the unit was built in 1978. In the next step I'm now removing all of the old components. The contactors and the timer relays can be salvaged and probably be reused. Many of the other components look cool, but the plastic has gotten really brittle over the years. With all the components removed from the old enclosure, I was now able to clean it inside and out, and I did that with my steam cleaner. After prepping the surfaces, it also received a new paint job. In order to close the holes in the door, I decided to cut away almost all of it and only leave an outer frame that I then used to glue a piece of salvaged aluminium sheet to it. I used MS polymer adhesive as usual. This way it will be possible to add new switches and indicators to the front panel if that should be necessary. The piece of aluminium will also have to be contacted to protective earth. Okay, so we have an empty enclosure. What's next? Well, I have been planning to build a photovoltaic system for my workshop for quite some time now. But since I don't own this property, I was a little reluctant to make any major investments into the building, up to this point anyway. I bought 40 of these 100-watt panels for a really good price. I saw inflation coming and thought that this would be a good investment even if I wouldn't be able to build a large system for whatever reason. In the 2 months since I bought them, they have already increased about 30% in price, by the way. And while I'm still planning to build a much bigger system sooner or later, I'm approaching the topic step by step. 2 years ago I put this 100-watt panel on my camper and made first experiences with this small system. The next step is now to build a 400-watt system that can be upgraded gradually, meaning that I could just add more panels to it if I want to. But the main objective here is to just build a functioning island system without spending any more money. For the first time in years I have all the components I need. And for the first test I will probably end up putting these solar panels on my camper temporarily, because whether or not I can actually use the roof for that also depends on the landlords. I'm not talking about attaching them to the camper. I will just put them there as long as the camper is not moved. I already have one of these chargers. I also have the big enclosure and lots of panels. What we will need next is an inverter and batteries. This is a UPS, which is short for uninterruptible power supply. Among other things, it contains a sine wave inverter with a maximum output power of around 2200 VA. A UPS is normally doing several things. Its job is to protect equipment, usually servers or business computers, from blackouts, brownouts, and other stability and interference related problems of the power grid. This particular UPS can do the following things: filter out some electromagnetic interference from the mains, step up or step down the supply voltage in case of overvoltage or undervoltage conditions, charge a 48 volts lead-acid battery stack from the mains electricity, generate a sinusoidal alternating voltage of 230 volts from the 48 volt battery, supply mains equipment with a maximum apparent power of 2200 VA for a limited time span. I bought this rather bulky unit a few years ago on eBay for around 40 euros. What I was always missing were the batteries, but through mere coincidence I recently got my hands on 4 brand new 12 volt lead-acid batteries. They were left over from a job and I got them for free. They would usually cost about 150 to 200 euros. These batteries are not ideal for photovoltaic systems, but they were free, so I'll use them until I have something better. Now, while all that might have sounded a little complicated, here is a practical demonstration. If there is no mains voltage present, the UPS will simply act as a sine wave inverter and you can power mains equipment from the battery stack. So what we are going to do is to charge the batteries via solar panels instead of the mains, and there you have a DIY island system. The first step was to take the UPS out of its old enclosure. With that being done, I took this opportunity to see how heavy the transformer really is. Its actual weight is around 10 kilograms, and according to an old rule of thumb, that would mean that it could maybe run at 1000 VA continuously without overheating. It also has a gap between the windings which will allow for better cooling, especially because there are fans on both sides forcing air through it. Just a word of caution: uninterruptible power supplies are designed to run at high power only for a short duration. Namely, until the server is shut down safely in case of a blackout or until the batteries are drained. So in other words, the power rating on the front panel is only a short-term power rating. It will overheat if you run it at 2.2 kVA continuously, but I think it will be able to run at a couple hundred watts for long durations, and we will just have to see about that. In case it overheats, it even has a heat sensor inserted into the transformer, by the way. In the next step, the UPS is inserted into the new, much bigger enclosure. In order to allow for airflow, I had to cut a hole into the top so I could install the bigger of the two fans here. The small fan that was probably intended to cool the batteries can only be installed after some of the metal sheets are worked on as well. In the next step, the solar battery charger is inserted as well. It was built for a couple of different voltage levels, with 48 volts nominal or 4 12 volts batteries in series being the highest setting. It is rated at 50 amps of maximum output current, even though I wouldn't bet on that. I also install a power meter measuring the output voltage, current and power factor. One word of caution: these cheap meters only work properly with sinusoidal voltages. The unit still needs more and better protective earth wiring, and the batteries need to be fastened properly. Some of the wire cross sections on the DC side could also be a little higher. But it's winter and I have to test this before whatever little sun we have now might be gone. So let's see if it works. I installed one of the bench grinders from a previous episode here, and it all seems to work as intended. With the solar panels lying almost flat on the ground and German winter sun, we achieved a little over 160 watts of power, and I think that that's not too bad. I'm happy to see that the system works, but of course long-term tests will have to answer questions such as, will the UPS be able to work long-term at acceptable power levels, and will the cheap solar charger actually be able to handle much higher currents than what we had in this test here? You will hear about that again in a few months from now, once we have seen a little more sunlight around here. Let us take a glance then at our mystery item of the day. When I found this on the scrap, I actually wasn't 100% sure what it was myself, since this is certainly a very rare item here in Germany. It is a mechanism from an old American rock-ola jukebox. And my greetings go out to the viewers in California, and especially to the city of Torrance, California, where the company seems to reside today. I cleaned this thing up a little bit, and then I even got it to spin. Just testing the motors here. 28 volts DC, pretty rare. You can see in the little picture how this is actually supposed to operate. This little 110 volt induction motor spins the records, of course, and that one seems to work as well. Now, of course, I won't be able to build a jukebox from just this part, but I guess I will just store it and eventually give it to someone who repairs jukeboxes and needs the parts. One other thing that I actually found a while ago is this post or blacksmith device, and I just keep finding them, or rather they find me. I have covered these repairs at least 3 times before, so I'll make it quick. And let me share some general thoughts while I work on this thing. I'm aware that there are many YouTube channels out there that produce way more content than me, and people sometimes tell me that as if I weren't aware of it. And while I absolutely appreciate that you are always waiting for new videos, let me just tell you that this has been the 29th Repair-A-Thon, and this happens to be the most time-consuming format I ever came up with. The thing is that every video takes between 100 and 150 hours of work. I have to drive around and acquire things, source parts, do research, and of course perform the repair or build. At the same time, I film and juggle hundreds of gigabytes of files for every video. And then you still need to edit and voice record, and when that time has passed, I haven't even answered one single viewer mail yet, which is work for that I don't receive any pay, and you can imagine what it means to have hundreds of thousands of followers. Now, don't get me wrong, I love what I'm doing here and I don't complain. I just try to explain why it always takes so long, and I've been trying to find people that I can employ here to take some work off my hands so that more videos can come out faster. But it's not easy to do that in the bureaucratic wasteland that this country is. But here is one thing you can count on. There will always be a new video. And I do all I can to keep the quality as high as possible, even if it takes pretty long. But I still need your support to keep this going. So please give this video a like if you think that there should be more of these videos. And in case you want to support me more actively, you can also make a donation via PayPal, links down in the video description, or become a supporter on patreon.com/tpai. See you soon.